let's consider a person, for example you, standing inside an elevator on top of a scale. And the elevator shall accelerate with acceleration L. Let us define the positive y direction going upwards. If we draw this as a free body diagram, we first define a coordinate system. We define here in this case positive y going upwards. We define positive x going towards the right. The mass of the person is just approximated by the point, and then we draw in all the physical forces that are acting on the person. The weight acting vertically downwards, the normal force exerted by the scale on the person is acting upward. And that is what the reading of the scale is. The scale reads the normal force of the person. Now I apply Newton's law. The sum over all forces acting in the y direction equals the mass of the person times the component of the acceleration in the y direction. Now, in the positive y direction we have n, in the negative y direction we have the weight of the person, that equals n in y. I can solve this now for the normal force. The normal force, which is the reading of the scale, is then m_ay plus mg. I can factor out the m to get m times ay plus g. From this we see now that should ay be positive, that means it is accelerating upward. That means from that it follows then that the normal force is greater than the weight. The scale reads more than the weight. Should ay be 0, that means the elevator is at rest or moving at constant speed, either up or down, that doesn't matter. Constant speed up or down is both ay equals 0. In all these cases, not moving or moving at constant speed, the normal force, which is the reading of the scale then, is just the weight. Should ay be less than 0, that means it is negative, the elevator is accelerating in the downward direction, then the normal force and the reading of the scale is less than the weight. Should the acceleration be minus g, that means essentially the elevator is in free fall. In that case, the normal force will go to 0. Should the acceleration be even more negative than minus g, from that it follows that the normal force will still be 0, but you will at some point hit your head at the ceiling. Head. Ceiling. And we could go ahead now and calculate actually what the normal force exerted from the ceiling on the person would be.